Hello, today we are going to talk about the IB Excel past paper on mathematics, paper 1, that is in TZ1. So in 2018, so let's get started about question 1, that is about the function. We have the function that is square root of x plus 2, and with the domain that is greater than or equal to negative 2, and gx, which is vx minus 7 for all real number. So it's now asking us to write down the function of 14. So we have the function x, that is square root of x plus 2, and then we just plug in a value in it. That's 14. So 14 plus 2 and square root it, which is square root of 16, and then we have 4. So that is for part A. And then for part B, is asking g of f of 14. So in the notation, we have 14 here. So we have g of f of 14. And previously we have found f of 14, which is 4. So it is asking g of 4. And then we have the function is here. So 3x. So 3 times 4 plus a minus 7, sorry, that is minus 7. So we have 12 minus 7, which is 5. So that is for part B. And it's asking us the inverse function of g. So how can we find the inverse function? Is by letting g of x. We know that that is y, and then that is equal to 3x minus 7, and then we just now let it to be x minus 3y minus 7. Oh, sorry, that should be in here. And then I will change the subject. Y became the subject. So we have x plus 7 over 3. So that is the function. And we now call that one as the inverse function of g, that is equal to x plus 7 over 3. So now I want to check that if it's correct or not. So this part is for checking. So if you think you're clear enough about this concept, you can skip it to the next question. So I'll now show it to you. G of the inverse of g of x. So g of the inverse of x of the function. So that is the function. And now just copy the inverse function here. And then on that function we have 3 times x plus 7 over 3 minus 7. And then that is just x plus 7 minus 7. So that is x. And then I will show the inverse function of the g of x. Inverse function g of x. The inverse function, keep that. And then this is just equal to 3x minus 7. And then I will plug in the inverse function into that. So that is the 3x minus 7, and then plus 7 over 3. So that is just x. So both are correct, just equal to x. So that is our inverse function. That's all for question 1. And now we got to question 2. This question about statistics, and now it's asking us the this is not showing the Boston whisker diagram, and showing the number of tests sent by students in school on a particular day. And now part is asking the value of the interquartile range. So for the interquartile range, what is this? So interquartile range. So that is the upper quartile. It's called Q3 minus the lower quartile, which is called Q1. And from this diagram, we know that that's Q0, Q1, Q2, Q3, And finally we have Q4. So from this diagram we know that Q3, which is equal to 11, for Q1, which is 4. So after subtraction, that is equal to 7. So that is for part A. And now we got to part B. One student sent K test messages where K is greater than 11. Given that K is an outlier, find the least value of K. So from this question asking, what is the maximum number that the student can send? So what is outlier? So we have to know what is outlier. So outlier mean, that is the biggest diverse from the mean. Biggest diverse from the mean. But here, it means that we can have the lowest outlier or the biggest outlier. So we have to specify that we want to find the maximum number. The maximum number of test messages that the student can type or can send, right? And then it means that for the outlier in the conceptual part, it means that 1.5 times the IQR, that is the biggest divergence from the mean, but we have to plus Q3, that's the upper quartile, so we can find the maximum number of tests the student can type. So 1.5 times 7, find previously, and then plus Q3, that is 11. So we can find it to be 10.5 plus 11, so that is 21.5. But we know that for the test messages, so this has to be countable value. It is a countable value, so that is 22. So the maximum number, that is 22 student can send. So that is for question 2. So now we get to question 3. So this question is about a function, and we're having a graph of function. So this function having a domain that is between -2 and +2. And for part A is asking us to write down the value of f of 0. So for the f of 0, what does it mean? It means that we want to find y when x is equal to 0. So what is y? So we can find it from the graph that when x is equal to 0, so that is 0, so we point to that value, so that is -half. So that is for part A1. For part A2, it's about the inverse of the function. So when the function is equal to 1, the value is equal to 1. So we have to sketch the graph first. So how to find the inverse of the function? We have to make use of the property of the mirror. So that is y is equal to x. So what does it mean is that when x is equal to 1, we can find the corresponding value, that is y is equal to 1, etc. So on and so forth. So we can, from this symmetrical line, the mirror, you can find the inverse of the function. So we're passing through this point, that point, and also this point, and then we can sketch it. And then here we got to the half. Yep. Yep, perfect. So that is the inverse. This is the function. That is the inverse of the function. And I was asking, what is the inverse of the function? So that is asking, and what is the domain of that when it be equal to 1? So we can find it, y is equal to 1. So when x is equal to 2, right? So that is asking when y is equal to 1. So what is x, right? So when x is equal to 2, y will be equal to 1, right? That is the corresponding value of that. And we can find the relation that is for function, that is for the inverse of the function. So when we want to find the domain of the function, correspondingly we can find the range of the function. So when we find the range of the function, so vice versa, we can find the domain of the function or the inverse. So for this one, it's about the range or the inverse. So it's asking the domain of the function. So from this graph, we can find that the domain will be here. Is from -2 to +2. So the inverse of the function would be -2 to +2, and this is about the range. So we used y to represent it, and we have sketched the graph. So we have to A, B, C. So that's it for question 3. And now we move on to question 4. This question is about quadratic equation and about the function of graph. So we have a function that is ax squared minus 4x minus c, and a horizontal line L intersect the graph at f x is equal to -1 and x is equal to 3. So we're having a function that is a quadratic equation. So we have a quadratic parabola, and there is a line intersecting at 2 points, that is -1, that is 3, and then at part A1 it states that the equation of the axis of symmetry, that x is equal to p. So we have a symmetrical line that x is equal to p. So how can we find p? In this question, we can find it very simply, is that find the midpoint of this function. So we know it is that is also p. So just to find p is by adding these two values, that is equal to 1. And then for part A2, that is p is equal to -b over 2a, because from the data booklet we can find that that is a property of finding the axis of symmetry of the value. And for the -b, from this we know b, which is equal to -4. So we have -4 over 2a, and that is equal to 1. That's what we found previously. So we can find a, which is equal to 2. So very simple. We just done part A, and then now we move on to part B. The equation of L is y is equal to 5. Find the value of c. So, and that is y is equal to 5. So this line is passing through this parabola, giving this two solution. So it means that f of -1 is equal to f of 3, and then that is equal to 5. From this we know that by plugging the value into the function, we have a times -1 squared minus 4 -1, and then minus c, which is equal to 9a minus 12 minus c, that is equal to 5. And the next step is to simplify that. So we have two equations, a plus 4 minus c is equal to 5. That is equation 1. And then we have 9a minus 12 minus c, which is also equal to 5. That is equation 2. And then we equate them together, So we have a plus 4 minus c is equal to 9a minus 12 minus c. So that is the next step. And then we can cancel the c. So we can find a that is equal to 2. Okay. That is what we have found before, but we can plug in this value into the function. So that is 2 plus 4 minus c is equal to 5. So we can find c minus 5. 6 minus 5 is equal to 1. So we can just simply do part B. So from this we can find A and C. Another approach to doing this equation, to do this question. So is by, for the first one is that the f of x that is equal to ax squared minus 4x minus c, and then we just plug in a value in it. Into the function. That's what we have found. That is equal to a plus 4 minus c, and then this one is 9a plus minus 12 minus c. That is 5, that is 5 all together. So we can find a, which is equal to 2. And then from this we can just plug in a value into that. So we can find that is 2. So we can find 1. So that is another approach to deal with this question. And then now we move on to question 5. This question is about integration and about to find the volume of under the graph. So for part A is to integrate a function, and we have the function given, which is 1/2 of square root 2x minus 1, then square root dx, and we know that x has to be greater than half. And then how can we do this integration? How can we do this integration? So we change that into index. So it becomes half of that, and the square root dx integrated, so it becomes 2x minus 1 negative 1 in the power, and then dx, right? But now I want to change that to 2x minus 1, and then half 2x minus 1, so there's no harm, alright? Okay, just do, yeah. So after this differentiation, I just let you to be 2x minus 1, and then we know that du will be just equal to 2 dx, right? So it means that dx is just half of du, so that's why I have half in here, right? And then now we have this function is written in here, u to the power of negative 1, and then du, and then this is just equal to half natural log u plus c, and c is just a real number, And this can be found from the booklet. So that is just equal to 2x minus 1 plus c. And for part B, is asking that the shade area that is called R is enclosed by the graph, and the domain is from x is equal to 1 to the x is equal to 9, and well, to find the volume of the solid. So how can we think about that? Is to think about the disk, the radius of the disk. So think of radius of the disk. Because we see that the disk, the radius of the disk is changing from time to time, right? So that is bigger, and then it's getting smaller and smaller and smaller and smaller. So it means that the disk, the radius of the disk is varying. So you change from x is equal to 1 to x is equal to 9. So we have to sum all these variables up. So by doing this, we have to do the integration of all the area. So it's from 1 to 9. So that is a volume. So we have to integrate all this area. So pi r square, right? But it changes from the y direction, so it's pi y square. And then dx, because we have to integrate from the domain that is the smaller changes of the x, so it's dx. And then we know that y is just a function of the graph, and then pi is just a constant, so we can just extract it out. 2x minus 1, and then square it, dx. And this is what we have found previously. So that is equal to half lateral log 2x minus 1, and then it's from 1 to 9, right? And then after calculation, we can find it to be lateral 17 minus lateral 1. And we know that lateral 1 is just equal to 0. So we have pi over 2 lateral 17. So that is for question 5. And then now we move on to question 6. And this question is about vector. So we see 6 equilateral triangles, each of the side, length 3 cm, are arranged to form a hexagon. And now it's asking us to find P dot P plus Q plus R. So from this, we can find that all the length, the scalar is 3. So it means that the magnitude of P, Q, R is also equal to 3. And it forms an equilateral triangle, so that is 60 degree, 60 degree. And then we can make a translation of the vector, so that is also equal to R. So from this diagram, we can see that P plus R is equal to Q. Okay, is equal to Q. So from here, we know that P plus Q plus R, so that is equal to Q plus Q. So we finally have 2Q, the vector. And now we do the question. P dot P plus Q plus R, that is equal to P dot 2Q, which is also equal to P dot Q times 2. So it's now asking P dot Q, and we know this formula is just equal to P of the magnitude and the magnitude of Q times the angle between them, which is just 60 degrees. So that is to find the projection of that vectors together. 2 times the scalar of P, which is just 3 cm. The magnitude of that is just 3, and then cosine 60 degrees. So we know that would be equal to 9. So that is for question 6. And then now we got to question 7. So this question we have 3 functions, f, g, h, x for all real number, and we have h that is equal to f of g. Okay, so that is a function of function, and it's given that g3 is equal to 7, g prime 3 is equal to 4, and g prime 7, which is equal to -5. And now it's asking the gradient of the normal to the curve. So how can we find the gradient of the normal? So firstly, we have the parabola, and we have a tangent line. For the normal, that means which is perpendicular to this tangent line. So we call this one as the slope of the normal, and that is the slope of the tangent. We note when these two values multiply together, we can have -1. And so that is the first thing we have. So we have the slope of the normal, that's 1 over mt, and we know that that is the function of h. So we have 1/2 the gradient of that, which is this h prime x, right? And now we have to do the differentiation of the function. So the x prime x, that is equal to f prime gx, and then we have to differentiate the inner function. So that is g prime x. So what I'm now doing is just doing the chain rule. So we have dy dx. It means that we have dy du times du dx. So that is what I'm now doing the chain rule. And then I want to find the gradient of the normal when x is equal to 3. So I have to substitute the value into it. g3 and then g prime 3. So far so good. And g3, that is equal to 7 as given, and then g prime 3, that is equal to 4, and then f prime 7, that is equal to -5. So that means -5 times 4, that is -20. So that is for the h prime 3. So how about the mn when x is equal to 3? That is -1 over h prime 3. So that is -1 over -20. So 1 over 20. So that's it for question 7, and that's it for section A. So that is the end of section A.